as track recording area is concerned. He has been associated with development of track recording cars, and I can say he is the master in the subject. Now I call upon the next paper presentation, Mr. Anil Kumar. He will be presenting paper on tunneling method and safety guidelines for adopted for construction of tunnel number 12 of Jirbam Tupul Imphal new line project in NFR railway.
Good morning, sir. In my presentation, I will be discussing the planning of long and deep tunnels as per the international safety guidelines. These guidelines are very essential requirement for the maintenance of tunnels in future, and these are being under implementation for tunnel number 12. Tunnel number 12, it is in Tupul Imphal section, which was sanctioned as phase 2 of Jirbam Imphal section project. This project is 111 km in which there are 10 stations. This is the satellite view of the project. Red color is indicating the tunnels. There are 46 tunnels in this project, comprising total length of 61 km. This project will be connecting the Assam Valley, near Silchar towards the Imphal. Key challenges of this project so far are difficult terrain, adverse law and order situation, short working season, poor telecommunication and road conditions. This tunnel is 10.28 km long with mining length of 9.32 km, rising gradient 170 with breakage in between, maximum overburden is 807 meter. Geology, shale, siltstone, sandstone, earthquake zone 5. One fault is there which is across the tunnel alignment at 90 degree almost. NATM method we are using in this tunnel. Since the area is prone to earthquake, for designing the final lining and deciding the maintenance tolerance, we are using the seismograph for taking readings and also the old data of the nearby areas. Now I will discuss the safety guidelines as per the international. Railway Board has authorized to use these two international guidelines for long tunnels. Railway Board also had issued guidelines for tunnels length up to length of 3 km. Normal single railway track in tunnel can be provided, but if it is more than 3 km, then we should go for safety methods for evacuation of passengers in emergency by the provision of lateral or vertical exit to the ground or parallel safety tunnels. These are also international guidelines where if we are providing lateral or vertical exit, then these should be at every 1 km. If it is length up to 150 meters, then cross-sectional area is 2.25 square meter, else it is more. If there is parallel safety tunnel, then cross passage which are connecting the main tunnel and parallel tunnel, it should be at every 500 meters. If these are not possible, then with modern equipments like ventilation, more ventilation, alternative technical solution to be provided. Escape walkway, which are very important during emergency, it is also classified, given that it should be minimum 0.8 meter with vertical clearance of 2.25 meter. Continuous handrail between 0.28 to 1.1 meter above the walkway should be provided. If tunnels are more than 1 km length, then firefighting point at outside the portal had to be provided with giving open area of 500 square meter. If the tunnel lengths are beyond 5 km, then additional firefighting at every 5 km inside the tunnel has to be provided. Firefighting point should be minimum 800 liter per minute pressure during first 2 hours. Position of lights are also important during fire. Smoke normally covers the above portion, so it should be at the lower level, normally built on the handrail, and proper signage for emergency equipments and exit doors has to be provided. For the tunnel number 12, for adoption of cross-section, as per international safety guidelines, 4 cases were discussed. Case 1 was railway tunnel accommodating the road in a single tunnel with a wider cross-section. Case 2 was for additional tunnel, normal single track. which can be used for doubling as well as escape tunnel. Case 3 was the similar of case 2 with a smaller cross-sectional area. And case 4, it is a normal single tunnel with edits at every 1 kilometer as per the guideline. Based on the techno-economical and local features, terrain, case 3 was approved. This is the schematic diagram of the project tunnel number 12, in which the blue color is indicating the main tunnel, and towards the Imphal end, there is exit, which is cut and cover and ramp portion. The green color is the parallel safety tunnel, which are interconnected with the cross passage at every 500 meters. For the speed up of the work, we have already constructed 2 edits, edit 1A and edit 1. Works from P1 end for both main tunnel and safety tunnel are in progress. In addition, other 4 phases in main tunnel started, and at 2 phases in safety tunnel started. We are hoping within next month, we will add all the additional next 3 phases. This is a cross-section of main tunnel where, as per the safety guideline, pathway for minimum width and vertical clearance is provided with the provision of handrail and firefighting equipment. This safe tunnel is a smaller cross-sectional area. Before the start of the work, we had to construct 30-kilometer approach road to reach at edits and portal portion. Land was finally awarded in January 17. After that, work at all places, including the approach road, are in full fledged. This is the picture of site where we see main tunnel and safety tunnel at 50-meter interval. In ATM, we already discussed, I think, limit. This, in the last presentation, it has been discussed. Survey is done for validation of alignment, then drilling, charging, blasting, ventilation done, mucking, scaling for removal of soft soils, loosened soil, then support basically consisting of wire mesh, lattice girder and shotcreting. These are the picture of the start of the work where we had constructed tunnels at portal 1 end, A, drilling, loading for blasting, charging of explosives. These are again scaling, mucking. But before any pull, we have to take phase log, which takes readings for deep end declination of the beds and other readings like joints, water ingress, soil conditions. Based on that, the soil is classified, and in an ATM with the soil classification, we design the support system. Shotcreting, rock holding, same we are doing. Since NATM is basically observational method, we are doing intensive monitoring in this case based on the different support class and on practical previous experience. Deformation tolerance has been decided, and if this goes beyond 50%, we have to take extra support, strengthening of the portion. It can be done with the help of additional rock board, shotcreting, or increased number of lattice girders. Readings for displacement, loads, and stresses on the shotcretes are being taken at regular interval. We see that after some time, these readings are being stabilized. At some locations, there are variations, but we have taken up. This may be some due to water ingress during the rainy season. It was there. This is the rock board load testing. Based on this, we have tackled cavities. Gases are there at Imphal Valley near P2 end, and in case of water in edit 1S, the gradient, edit is down gradient, so there water was accumulating and it was hampering the work progression. But now we are able to dewater all the water, and now we are going also for chemical grafting. So this program so far has been tackled and work started at that location also. These are the pictures where we are diverting water from, which were coming from the face towards the other end. Cavities were filled with the sandbags, and thereafter shotcreting was done. This is the water accumulated at the face, which was dewatered. Methane gas were there, some suspicions are there. If it is more than 5%, We measure it with methane meter, what should be stopped. Thank you, sir. This is the Manipur. We are Imphal station we are proposing, sir.
Thank you, Mr. Anil Kumar. It was a very good presentation on construction of long tunnels and safety measure. Now I'll call upon Mr. Satya Prakash Mishra, Principal, Indian Railway Track Machine Training Center. He will make a presentation on on-hand training on damping simulator for optimizing track maintenance by track machines.
My topic for presentation is on-hand training on damping simulator, which has recently been installed in IRTMTC. The track is being maintained by track machines, as everybody know, and with the increasing traffic and axle load, the importance of track machine is increasing day by day. Presently, we are using different type of machines like WST, CSM, Unimat, Damping Express, etc. Key to effective result, like everybody is using damping machines, but the results are not as desired, only because of the some weaknesses with the operators and some skills required and some training part also. So there are 4 important parameters which are corrected by the use of damping machine, mainly Versine, cross level twist and this longitudinal level. Speed and safe running of train also depends on these 4 parameters. So on-hand training on simulator is basically meant to train the operators for better utilization of the damping machines and for optimization of the track parameters with the maximum available capacity of the machine. We can see a study was done by RDSO in C121 report, and by that report one can see that the effect of bad alignment is much more in creating the lateral acceleration as compared to the current deficiency. So we should see while analyzing the results which we will get after the damping through DRP, that how we can optimize the parameters. Like we must see that the parameters which are achieved, which could be changed with the help of these reports, like as I have already said, that the effect of current deficiency in increasing the acceleration is much less as compared to the alignment defect. This is the formula by which we calculate the current, and as we know that if we have a very higher current, then there are more chances of development of twist, which is very serious for the safe running of the trains. So in this simulator we have DRP, that is called data recording processor, and which records all the parameters which I have already discussed, like 4 parameters, and those parameters we can see in graphical form, as well as we can also take out a print in A3 or A4, and then we can analyze those parameters. Safe speed can accordingly be calculated with the help of those parameters. This is the graphical view of the all these parameters we can see in DRP that is provided in the simulator. Basically, we are doing damping for the correction of track geometry to get the desired parameters as per our PV manual and other requirements for safe running of train. So fundamental system of damping, this is based on 2 systems, mechanical system and electrical system. All damping tools apply same pressure to the ballast independent of the movement of their movement. And electrical system, there is a closed loop control system. Actually, in automatic control system in which an operation process or mechanism is regulated by feedback. This is the example of closed loop system. This is the way how the machine works. Like it will continue to work till the input and output are equal. Means what we desired and what the input is there. So these are the abbreviations. Automatic guiding computer is also available in the simulator as well as in all the modern tamping machines. This is used for the measurement of the parameters. CMS is also for displaying the track parameters. Computer working system is also available in the CMS. It is very helpful and for the working of the machine. Data recording processor I have already discussed. The simulator which is available is having 200 meter of track, and we can record and time, and then we can check the parameters. Factors affecting quality of work is basically condition of and calibration of machine and skill of operator. So operator must be trained properly so that he can get the best out of the machine. So we have a tamping simulator which has front cabin tamping working cabin. So this is a 1.5 minute video of the simulator, that how it works. We have 200 meter of track, and accordingly we can measure the parameter and then optimize those parameters if required. So there was a real feel of the so you can see that it was a real feel of working in the machine. So now we have started the training of ALC, CWS, CMS to all the operators for the better use of machine. Future planning is that we want to train all the operators, and this course we have proposed to make mandatory for all those operators who are working in other machines, and they are now being posted in the tamping machines, so that without training at IITBC, they should not be given this tamping machine. Thank you.
Yeah, thank you very much. It was a very nice paper. The next paper is by Mr. Sandeep Kumar Saha, Division Engineer. It is on study of dynamic characteristic to detect railway ballast damage and application in structural health monitoring.
Good morning, sir. My topic is study of dynamic characteristics of to detect the railway ballast damage and application in structural health monitoring. In the modern age, we are going towards the fast, reliable and safest system. In axle load also increasing day by day. As the most of the Indian railway conventional system is the ballasted track system. So ballast degradation with the increase of the dynamic loading and the axle load is even more and more. With the increase of loading, a ballast assembly will vibrate at its own amplitude. When in a certain critical speed or the certain speed potential, it match with the certain critical amplitude. It may cause the serious safety issue. It may cause the resonance. And ballast retentivity of holding the sleepers on rail position is reduced gradually as it gives the longitudinal and the lateral stability to the track. So a fast real-time ballast detection method is need of power. The basic concept is to develop a ballast system based on the elastic foundation system, based on the stiffness approach. Stiffness approach means the load for the deflection for the unit load given, and for the any dynamic system, the mass matrix and the stiffness matrix is developed. For the calculation of the dynamic property by the basic equation of dynamics, the mode of vibration also calculated. These are the model or the numerical model. The rail is developed as a lump mass, and the model this connection is developed with the spring dashboard system. Below the yellow portion is the this sleeper system, and that below it is connected by the rigid element with the spring stiffness given to them, and it is modeled with the 4 degrees of freedom system. This 2 translation, 2 rotational. It is done in the it can be done in any standard stiffness based approach software. This element stiffness matrix taken from the Timoshenko beam model, and this after assembling the mass matrix and the stiffness matrix, we solve it by the eigenvalue problem, and the mode shape and the natural frequency is calculated by them. The model parameter I have done for the 260 kg UIC rail, and RDSO drawing follow the 2496. So we can take the model for the 52 kg rail also, and the basic assumptions are taken that in the undamaged condition, this all the demand stiffness will be the same, and the mode shape larger mode shape taken as a unity, and the rail seat under the rail seat, the changes in frequency will be the same. These are the mode shape calculated after the dynamic analysis by the softwares, and the first mode shape is the for the translation mode of vibration, and the second most involves only the deformation of the ballast, not the slipper, and the third mode shape is rotational degrees of freedom based on the rotational degrees of freedom, and these are the comparison and the natural frequency calculated by the dynamic analysis. These are the several cases I have considered. This 50% reduction in stiffness from the undamaged conditions and the 90% reduction in the stiffness. 90% reduction in stiffness mostly occur when the ballast become totally dust or the puncturing will be occur, and there is a need for the deep scanning after the full cycle of the ballast. And these are the calculated the natural frequency for the 50% reduction in the stiffness. You can see from the data also that the Morse third number Morse, the rotational degree of the freedom is more predominant. These are the comparison. The case 4 I have told that the 90% or the 50% reduction in the stiffness in the